Hi guys, my name is Christopher Roach and I'll be your guide throughout this series of screencasts on Node.js. In this series we'll be using Node to create a simple blog engine, like the one made famous in the popular Ruby on Rails introductory video. The goal of this series is to give you, the viewer, a real feel for how Node works so that even when you're working with any of the popular web development frameworks out there, such as Express or Getty, you'll feel comfortable enough with the inner workings of Node to be able to drop down into its source and make changes to suit your needs if necessary. Before we get into some of the details of what Node is and why you'd want to use it, I'd like to go ahead and get us started with the installation of Node, since though super easy, can take some time. Node is still very young and in active development, so it's best to install from the source. That said, Node has very few dependencies, and so compilation is nowhere near as complicated as other projects you may have fought with in the past. To get the code, go to the Node website at nodejs.org. If you scroll down the page to the download section, you'll see you have a couple of choices. First off is a link to the Git repo. If you have Git installed, you can just clone that repo and install from there. The second option, right below that, is a link to a tarball, and this is probably the easier option and the one we're going to go ahead and go with in this video. So if you click on that link and copy the URL, I'm going to open up Terminal and cd into my downloads directory. Then I'm just going to curl that link into the downloads directory. And while this is running, I just want to go ahead and mention that there are efforts that are ongoing to provide a port of Node for Windows. There are instructions for installing on Windows for Cygwin or MinGW, and I believe you can even find some binary packages out there that you can install. But at this time, its main environment is Unix and Linux-based platforms. So if you're on a Windows machine and you don't want to install a version of Linux such as Ubuntu, and you don't mind a little bit of pain, you can go ahead and come back over to the website and you'll notice down here a line that says for build instructions C. Below that is a link to the wiki page on installation techniques that you can use. If you click on that and just scroll down a little bit to step 3B, you'll see a list of instructions on building on Windows. Follow those and I'm sure you'll be up and running on Windows in no time. So let's go ahead and come back over to the terminal now that our download is complete. And let's untar and unzip that package that we just downloaded. cd into the new directory that was created. And now we're going to go ahead and do our install. Installation is super easy. It's just your typical configure, make, and make install that you see with most Unix and Linux installations. So go ahead and type in /configure and run that. Should take a second or two. There we go. Then you want to type in make and make install. So that's going to run for quite some time. So I'm just going to let that run in the background, and I'm going to take this opportunity now to talk to you a little bit about Node and why it's causing such a stir in the web development community. So if this video is your first introduction to Node, you're probably wondering just what it is and what makes it worth learning when there are already so many other web development frameworks out there to choose from. Well, for starters, one reason you should care is that Node is JavaScript on the server. And let's face it, if you work on the web, love it or hate it, you're going to have to work with JavaScript at some point. Using JavaScript as your back-end language, as well as for the client side, means a whole lot less context switching for your brain. Oh, I know what you're thinking. So Node is JavaScript on the server, and that's great. But there have been other JavaScript on the server attempts in the past that have basically just fizzled. What makes Node any different from the rest? Well, the short answer is Node is server-side JavaScript finally done right. Where other attempts have basically been ports of traditional MVC web frameworks to JavaScript language, Node is something entirely different. According to its website, Node is Evented IO for V8 JavaScript. But what exactly does that mean? Well, let's start with V8. V8 is Google's super fast JavaScript implementation that's used in their Chrome browser. Through some really ingenious application of just-in-time compilation techniques, V8 is able to achieve speeds for JavaScript that make users of other dynamic languages, such as Python and Ruby, green with envy. Just take a look at some of the benchmarks, and I believe you'll be amazed. V8 JavaScript is up there with many JVM-based languages, such as Clojure and Java, and compiled languages such as Go in many cases. The other key phrase in that statement is Evented IO. This one is really the biggie. When it comes to creating a web server, you basically have two choices to make when dealing with multiple concurrent connection requests. The first, which is the more traditional route, and it's taken by many web servers such as Apache, is to use threads to handle the incoming connection requests. The other method, the one taken by Node and some extremely fast modern servers such as Nginx and Thin, is to use a single non-blocking thread with an event loop. This is where the decision to use JavaScript really shines, since JavaScript was designed to be used in a single-threaded event loop-based environment, the browser. JavaScript's ability to pass around closures makes event-based programming dead simple. You basically just call a function to perform some type of I/O, pass it a callback function, and JavaScript automatically creates a closure, making sure that the correct state is preserved even after the calling function has long since gone out of scope. But this is all just technical jargon, and I'm sure you're just dying to see some code in action. So I'm just going to fast forward a bit to the end of this install so we can start playing around with our brand new, freshly minted copy of Node. So it looks like my build is finally finished, and I want to just quickly check and make sure that everything went well with the install. To do so, simply run node -- version from the command line. And you should see some indication that you're running the latest version of Node, which at this time is version 0.4.5. If you see a version print out, then you can rest assured that everything went swimmingly and you're ready to write your first Node app. So let's cd back into our home directory and create a new folder to hold all of our work during the course of this series of screencasts. Here I'm just going to call mine blog, and now let's cd into that directory to get started. So unlike other frameworks, Node is not strictly for web development. In fact, you can think of Node as a framework for server development of any kind. With Node, you can build an IRC server, a chat server, or as we'll see in this set of tutorials, an HTTP server. So since we can't have an introductory tutorial without the obligatory Hello World application, we'll go ahead and begin with that. Let's create a new file called app.js. Now Node comes with a handful of libraries to make the development of event-based servers easy. To use one of the available libraries, you simply include its module using the require function. The require function will return an object representing the module that you pass into it, and you can capture that object in a variable. This effectively creates a namespace for the functionality of any required module. For the creation of an HTTP server, Node provides the HTTP library. So let's go ahead and require that now and assign the return object to the HTTP variable. Next, we'll need to actually create our server. The HTTP library provides a function called createServer, which takes a callback function and returns a new server object. The callback function is what Node calls a listener function, and it is called by the server whenever a new request comes in. Whenever an HTTP request is made, the listener function will be called, and objects representing the HTTP request and response will be passed into the function. We can then use the response object inside of our listener function to send a response back to the browser. To do so, we first need to write the appropriate HTTP headers. So let's call the writeHead function on our response object now. The writeHead function takes a couple of arguments. The first is an integer value representing the status code of the request, which for us will be 200. In other words, OK. The second value is an object containing all the response headers that we'd like to set. In this example, we'll simply be setting content type to be text/plain. That way we can send plain text back to the browser. Once we set the headers, we can send the data. To do that, you'll call the write function and pass in the data that you want to send. Here, let's call the write function on our response object and pass in the string hello world. To actually send the response, we need to signal to the server that we're done writing the body of our response. And we do that by calling response.end. The end function that we just called also allows us to pass in data as well. So we can shorten up our server code by getting rid of the write function that we called earlier, and instead passing in our hello world string to the in function that we just called. Now that we've created our server, we need to set it up to listen for new requests. That's easy enough to do. Just call the listen function on our server object and pass in a port number for it to listen on. In our case, we're going to use port 8000. The listen function also takes an optional second parameter, which is the hostname URL. But since we're just running this locally, we can safely skip that parameter for now. Finally, let's print out a message to let us know that our server is running and on what port it is listening for new requests. You can do that by calling the console.log function just like you would in the browser and passing in the string listening on http://127.0.0.1:8000. This basically just gives us the URL that we can copy and paste into our browser and just reassures us that our application is actually up and running. So let's save that and flip back over to the terminal. To run the app, call the node command and pass into it the name of the file that you want to run, which in our case is app.js. If you hit return, you should see the message that we created earlier, listening on, and it'll give you the URL and the port number. So go ahead and copy that and skip over to the browser. Create a new window and paste that in, and boom, there you go. Hello world, your first Node app up and running. Before we bring this first video in the series to a close, let's flip back over to the terminal and quickly take a look at Node's REPL. A REPL, for those unfamiliar with the acronym, stands for Read Eval Print Loop, which is nothing more than a simple program that accepts commands, evaluates them, and prints the results. It's essentially an interactive prompt that allows you to do, well, pretty much anything that you can do with regular Node, but without all the overhead of creating a separate file. And it's great for experimentation. So let's just go ahead and play around a bit with the REPL and learn a bit more about Node in the process. We'll first need to stop our server application by hitting Control-C. Then we want to run Node again, this time, however, without a file name. Running Node without any arguments will bring up the REPL, as we can see here with a change in the prompt. The REPL is very simple. Basically, you can write JavaScript code and see the evaluation of that code. Despite its simplicity, though, the REPL does have a few commands that can come in handy, and you can get a good look at each of these by calling the .help command at the prompt. Here we see a list of 4 commands, the first of which is the .break command. If you're writing some code that spans several lines, and you find that you made some type of mistake and need to break out for whatever reason, the .break command can be used to do so. Let's go ahead and give that a try now. I'm just going to create a function here, and I'll call it foo, and open up the function body and hit enter. Now notice that on the next line, rather than seeing the typical greater than symbol, we now see a set of 3 dots, or an ellipsis. This is Node's way of indicating to us that we have not yet finished the command on the previous line, and that Node is still expecting more from us before it evaluates the code that we've just typed in. So let's go ahead and add a line of code now. I'll go ahead and go with just a simple print out. I'll do console.log and I'll print out the name of the function, nothing special, and hit enter. Notice again that we see the ellipsis once more. Node is still expecting us to finish the function eventually. Now let's go ahead and assume that I've made some type of mistake and I just want to get back to a normal prompt. If I continue to hit the enter button, notice that Node just continues displaying the ellipsis character. But if I call the .break command, Node will break us out of the current command and take us back to the normal prompt, just like we wanted. The next command on the list is the .clear command. This one will clear our current context. So if you've cluttered up the environment with the creation of several variables and functions, and you just basically want to get back to a clean slate, simply run the .clear command, and voila, everything magically disappears. So let's go ahead and give that a try now. I want to first create a couple of variables. We'll go with a equals 5, and we'll create another b variable, and we'll call that foo. And we'll just go ahead and throw a function in there, just for good measure. That'll print out, let's print out our b variable. What about that? So if we call each of these, we can see our foo command prints out b. B shows us value of string foo, and a equals 5. But if we now call our .clear command, you see a print up saying clearing context, and if we try and call a then, we'll get a reference error because, well, a doesn't exist. What about foo? Let's just give that a shot real quick. And same thing again, foo is not defined. So we've cleaned out the whole context just by calling .clear. Finally, there's the .exit and .help commands. The .help command is fairly obvious since it's the command we use to see the list of commands in the first place. The .exit command is equally obvious. You essentially just call it to exit the REPL, like so. So that pretty much covers all the functionality that the REPL provides outside of the evaluation of the code that you enter. But before we leave the REPL completely, I'd like to take this opportunity to discuss some differences and similarities between JavaScript in the browser and Node's flavor of JavaScript. So let's run Node again and jump back into the REPL real quick. The first difference between client-side JavaScript and Node is that in the browser, any function or variable created outside of a function or object is bound to the global scope and available pretty much everywhere. In Node, though, this is not true. Every file, and even the REPL, has its own module level scope to which all global declarations belong. We'll see this put to use later in the series when we discuss modules and create a few of our own. But for now, you can see the actual module object for the REPL by typing module at the prompt. Notice that there is a prompt attribute buried a few levels deep in our module object. This controls the prompt that we see when in the REPL. Let's change that to something slightly different and see what happens. So we'll type in module dot exports dot, where is it? It's inside of the REPL object. And finally we see prompt. If I just hit return now, we'll see the greater than symbol with a space following it. And that's basically been what we're seeing the whole time we've been in the REPL. So let's hit the up arrow and bring that back from history. And we'll set that equal to, let's do equal and a greater than symbol and a space. So there we go, something slightly different. Hit enter a few times and we can see our new prompt. Another difference between Node JavaScript and browser JavaScript is that in the browser, you have a global window object that essentially ties you to the browser environment. In Node, there is no browser, and hence no such thing as a window object. Node does, however, have a counterpart that hooks you into the operating environment, that is the process object, which we can see simply by typing process into the REPL. It's a fairly large object, and if you want to see everything, you're going to basically have to scroll up the screen a little bit to see all of this. But it pretty much is just about everything that has to do with your environment. You'll notice in here you have a version, you have a title, which is Node obviously. I believe if let's try this out, we'll type in process.pid, and that's actually the process identifier for the current Node process that you're running. Another thing is, let's do process.env, and these are all the environment variables that you're currently seeing in Bash or whatever environment that you're running Node from. So one similarity that I'd like to point out here now is the set timeout function. If you're familiar with client-side JavaScript, you've no doubt used this function a time or two. It basically lets you set up a function to be called at a later time. Let's go ahead and try it out now. We'll create a function, and I'm going to call it say hello, and it's going to take a number of seconds. Let's just go ahead and open that up, and it's going to print out console.log. It's going to print out hello, and on the next line we're actually going to call our set timeout function, and we're going to pass into it our callback, and that callback is just going to basically print the second part of our message, which is world. Now let's close off that callback, and we'll take the number of seconds and multiply it by 1,000, since set timeout actually takes milliseconds. And finally we'll close off our function. So this is going to create a function that when called prints out the string hello, and then a few seconds later, depending on what we enter, it'll print out the string world. So let's go ahead and execute it now, and I'll pass in 2 seconds to it. So there we see our first string, hello, And 2 seconds later, there we see our second string world. So there's a couple of important ideas to take notice of here. First, Ryan Dahl, the creator of Node, has done his best to make the environment as familiar as possible to anyone with client-side JavaScript experience. So the use of names such as set timeout and set interval, rather than sleep and repeat, was a conscious decision to make the server-side environment match, wherever it makes sense, the browser environment. The second concept that I want you to be aware of is the really important one. Notice that when we call say hello, right after printing the first string, control is immediately given back to the REPL. In the time between when the first string is printed and the callback function executed, you can continue to do anything you want at the REPL's prompt. This is due to the event-based nature of Node. In Node, it's nearly impossible to call any function that blocks for any reason, and this holds true for the set timeout function as well. Let's call our setHello function again now. However, this time let's pass in a slightly longer timeout interval to give us enough time to play around a bit and prove our point. I believe 10 seconds should probably do the trick. So let's go ahead and call our sayHello function, and we'll pass in 10 seconds to it. And then we'll go ahead, we see the hello string print out. Let's go ahead and add some code of our own. Let's do a 2 plus 2. There we get the answer of 4. Excellent. And if we give it a few more seconds, oh, there we go. The string world prints out. So you can see that basically all functionality is being returned back to the main event loop, which in this case is the REPL. And that pretty much serves as a really effective example of just how great or what the most important part of Node.js is. And that's that concept of this single threaded environment with an event loop that basically makes your code super efficient and extremely fast without using threads to bog down the CPU. So that pretty much brings us to the close of the first episode in this series. I hope this has been a fairly informative introduction to Node for you, and I hope I've done a decent enough job of explaining why it's so exciting, what it has to offer, and just how fun and simple it is to use. In the next episode, we'll actually start writing some of the code for our blog engine. So I hope you'll all join me again for the next episode when things get a little bit more hands-on and a little more fun. I'll see you then.